Hello again hello once again, everyone, rather. Let's keep talking. Let's look at test number 4. It pertains to geometric figures and some trigonometry and things of that nature. What to talk about first, I guess you could say. Well, some of the things that I'll say regarding test number 4, I think is going to have some application to test number 5. So the things that we do with test number 4, I'll say a few things in addition to some of the things that are specifically for test number 4. They'll pertain, I guess, to test number 5 when we talk about measurement. So let's talk here a little bit, you guys. If I were to talk about the length of a figure or its circumference, or generally its perimeter. I mean, circumference is a kind of perimeter. Perimeter means the measurement around. If we're talking about something like this, you're talking about meters, inches, feet, miles, kilometers, etc. Let me just keep one of the units, I guess, to kind of get an idea here. It's a linear unit. It's not being squared. It's not meters squared or meters cubed. It's just meters. When you talk about area, and this applies a lot to practice test number 5. I'm getting ahead of the ball game a little bit, but that's all right. When we get to practice test number 5, we don't have to say this again. We see it in practice test number 4. When we talk about area, we talk about meters cubed, inches cubed. Forgive me. When we talk about area, we talk about inches. We talk about area, we get meters squared, inches squared, feet squared, miles squared, kilometers squared. Once again, square units. Just something to talk about. I think it's good to bring this stuff early before we get to practice test number 5. So when we get to it, it's not going to be quite as intimidating to us, perhaps. So we look at this, and let's see. A number of ways you can do this, trying to keep this symmetric, I guess, how things look. Volume, you talk about meters cubed. Inches. Inches cubed. Feet cubed. Miles cubed. Kilometers cubed. And again, so again, this is of interest. How do we do things? Well, yeah, I mean, this makes sense. Notice how I kind of said it differently. I talked about meters. I talked about meters squared. I talked about meters cubed, or kilometers cubed, or miles cubed. Here, meters squared, kilometers squared, miles squared, meters, miles, kilometers, whatever. They always say 1 meter, 1 square meter, 1 cubic meter. That's okay, but be careful. It's really meters cubed. Right here, it's meters cubed. Here, it's area. So volume, meters cubed, area, meters squared, perimeter, meters. I guess a good way to look at it is, if you're talking about a one-dimensional phenomenon, just measuring length, whether it's around a curve or not, one-dimensional phenomenon, talk about a meter. When we talk about two-dimensional phenomenon, meter squared, meter to the 2 power. So that's kind of interesting how that works out. So maybe that's kind of a good mnemonic device, be able to remember. Three-dimensional phenomenon, meters cubed. True. Very important. What you don't say, when I say to you 100 cubic meters, that means a meter by a meter by a meter, a meter by a meter by a meter, that's 1 cubic meter. 100 of those is this. That is not the same as 100 cubic meters. It sure looks like I should say it that way. I say cube first. This right here, when you actually cube it, becomes 1,000,000. It becomes 1,000,000 meters, so it's not even a volume under consideration, and the number is way off. So be careful. Whenever you're saying this, don't ever put the cube next to the number. Put the cube, or the square for that matter, put the square or the cube as far away as you can to the far right-hand side next to meters or inches or feet or miles or kilometers or whatever. Make sure that the cube is to the far right next to the unit of measure. The cube or the square is to the far right next to the unit of measure far away from the number. This is how you write it. Not this. This is absurd. So just watch out, okay, when you're doing something like that. Because there is one-dimensional considerations, two-dimensional considerations, and three-dimensional considerations, it means something. Let me give you an example. Centi has the Latin base pertaining to 100. A centurion was a commander of 100 soldiers. In Greek, because Greek and Latin were spoken in the Roman Empire. In Latin, centurion, commander of 100 soldiers. In Greek, again, both languages were spoken in the Roman Empire. It's ekatondarchos, leader of 100 soldiers. Centurion or ekatondarchos. Well, let's use centi. How many cents are in a dollar? 100. How many years are in a century? 100. A centurion, commander of 100 soldiers. A centimeter is 100 times smaller than a meter. If it's 100 times smaller than a meter, you need 100 times the amount to equal a meter. If I can walk across a room with 5 big steps, or I can walk across the room with 20 small steps, it doesn't mean that I'm walking any kind of different distance. The distance is the same. What's happening is, because the steps are smaller, each small step is actually 4 times smaller. I need 4 times as many of those steps to cover that same distance. What's 4 times 5? 20. I need 20 small steps to cross the room rather than 5 big steps. It is about steps. The fact that you need a lot of these, you need 100 of them, each one of these is 100 times smaller than a meter. That's why I need 100 times more of them to get that. If somebody were to say this to you, now you got to be careful. I kind of delivered this speech. 1 meter squared, that came from 1 meter by 1 meter. That's where it came from. Yeah, what does that mean? Well, we already said every meter is 100 centimeters. (100 times 100), 10,000 square centimeters is the same as 1 square meter. Wow. I thought it'd just be 100 times bigger. Well, it's 100 times bigger in one direction. And there are two directions, each perpendicular to one another, that you have to account for. There's, how many little squares are there going to be? Well, there's like 100 edges here and 100 edges there. At the end of the day, 100 times 100 is 10,000 little squares. They're going to call the shots there. Pretty interesting. Pretty interesting regarding that. So if you go 1 cubic meter, that means 1 meter by 1 meter. They're all perpendicular to one another when you're doing the measurement. 1 meter by 1 meter by 1 meter is the same as, well, we just said every meter is 100 centimeters. Wow, you're not just going to put 100 there and say, oh yeah, it's the 100 cubic centimeters is going to give me 1 cubic meter. It doesn't work that way. Because you're dealing with 3 dimensions, you will have to do a multiplication. This thing will be to the power 3 more, to the power of 100 times, to the power of 100 times more, to the 100 to the power 3 to get the cubic meters, 100 to the power 2 Here you're squaring. You're squaring this. Well, yeah, it was a square meter. Here you're cubing this. This guy's not the only one getting cubed, it's the 100. And that comes out to 1 million cubic centimeters. So you got to look out. You got to look out. 1 foot is a length of 12 inches. I agree. 1 foot squared is 1 square foot. That's 12 inches by 12 inches. That's 144 inches squared. That's what this is. So you're looking at it, you say, okay, well, that's that, that's that. This right here is the same as that. It's coming out to here. So on and so forth. 1 foot cubed, a foot by a foot by a foot, is 1 cubic foot. I agree. That is 12 inches by 12 inches by 12 inches. The quantity 12 inches cubed. Well, okay, I'm probably going to try to do this one in my head again. Hopefully it doesn't go too bad. 12 times 12 is 144. Times 12 is 1,440 plus 288. 1,440 plus 288 is 1,728. Let's have a look here. Make sure I got I think it's 1,728. Inches cubed. Wow, it gets so the numbers get bigger. Well, yeah, you're going into 3 dimensions when you're trying to do this. Okay, just make sure that's right. I could maybe jump on my calculator real quick to be sure on that. But I don't want to get too much in that adventure. Sometimes I'm right, and other times I'm not always going to be right. But that happens, I guess. 12 times 12, 144. Times 12, again, I said 144 times 12 is 1,440 plus 288. I'll say 1,728. I'm going to stay with that. I'm going to not even go to the calculator. Look at how this stuff plays out, you guys. And that's what we've been talking about here. So you got to look out for what's happening. Be very careful. There's some formulas here. We'll talk about that. Let's proceed a little bit. Again, just be aware of the steps. And the more you go into different dimensions, higher level dimensions, the numbers get pretty big because you're going to need a lot of the small stuff in an exponential sense, so to speak. You can't just say, oh yeah, the difference between 1 meter and a centimeter, they differ by a factor of 100. Yeah, okay, you can say that. I mean, depending on how you're going to use the language, I guess, you can say that. But if I'm talking about 2 dimensions for area or 3 dimensions for volume, the difference is not just 100 times more like it is for length and perimeter. It's it's 100 squared for area, and it's 100 cubed for volume. That's why I was getting, 1 meter is 100 centimeters. 1 square meter is 10,000 square centimeters. 1 cubic meter is 1 million square centimeters. Again, it's 100 to the 1, 100 to the 2, 100 to the 3. In terms of feet and inches, 1 foot, 12 inches. 1 foot squared, 144 square inches. 1 cubic foot, 1,728 cubic inches. So again, it's 12 to the 1, 12 to the 2, 12 to the 3, where we're getting 12, 144, 1728. Okay. There are things that get said, I guess, and I'll say them here. We see them in the book. We'll talk about it in class as well, however we need to do so. But we've got this famous, and I have it in another film. I have a proof of this theorem. It's a famous theorem. The proofs, I'm sure I'm not the only one to have done it, and what I'm doing is not unique. This was done long before I was doing any of this stuff. But if you look at a right triangle, 90-degree angle here, the longest side's called the hypotenuse, and the legs are called A and B. You don't know which one, you call either one whatever you want, however they want to label it. So this C squared equals A squared plus B squared is the relationship that exists in any right triangle in the universe. True. If there's an angle theta here, they got this thing called the sine of theta, the cosine of theta, and the tangent of theta. The sine of theta is whatever's opposite the angle, lengthwise, divided by the hypotenuse. That's A over C, opposite over hypotenuse. The cosine is what's adjacent to the angle divided by the hypotenuse. In this case, it's looking like this. And the tangent is basically the rise over the run. It's opposite over adjacent. That's A over B. A lot of times, if you already know what this ratio is, whatever it might be some value x. Maybe let's say x equals this ratio, whatever that may be. If somebody were to say to you the inverse sine, this does not mean, guys, this thing right here, if I were to say the sine of x to the -1 power, indeed it really does mean this. It does mean that. This doesn't mean that. It doesn't mean 1 over that. It means give me the ratio, forgive me, give me, theta is not a good word for it actually, given this x right here, give me the ratio from which this came. Forgive me, give me the angle from which this came. This is the ratio here. This is a ratio, some ratio. This is some number. It's not written as a fraction. It may be written like 0.5, 0.6, whatever. The inverse sine of this is the angle from which it came. What angle got me there? So you might get, like I said, you call this guy this. This guy could be B over C, could be Y. What is the inverse cosine of Y? And Y is equal to this. That would still be theta. The inverse tangent. Again, when we do some of the problems live, you guys, we'll call this thing Z right here. The inverse tangent of Z came from theta. Now, it doesn't have, there's a lot of things here. Basically, the argument is this. If they give you an angle, you'll find some ratio associated with the angle. And that ratio, basic trigonometry, is sine, cosine, tangent. The sine of the angle is A over C. The sine of theta is A over C. The cosine of theta is B over C. The tangent of theta is A over B. So, but if you already got the ratio somewhere and you want to find the angle from which it came, then you go inverse sine and you get it like that. Okay. We'll see this when we work on it a little bit. It's a lot of stuff here, guys. Basically say if you're talking about, let's say, a circle, radius r, the diameter is double the radius. What's the circumference? The circumference is 2 pi r. What's the area of the circle? Pi r squared. If you've got a sphere, I don't know if I drew this any good at all here. If you got a sphere, radius r, the surface area of the sphere is 4 pi r squared. The volume is 4/3 pi r cubed. Talk about any rectangle, even a special rectangle called a square. If that's length and that's width, area is length times width. If it's any parallelogram like this, and it's got, like, let's say a height h and a base b right here, area is base times height. If you cut this parallelogram, again, this has got to be, not a good drawing here, guys, but these two are parallel to one another. These two are parallel to one another. If you can construct it to look any way you want, if you cut it in half, you'll have half the area. Well, if you cut it in half, you got a thing called a triangle. Because this triangle doesn't have to be a right triangle, guys. This triangle came from some kind of parallelogram, where this is b and this is height, and we get this. If you've got a thing called a trapezoid, well, these aren't the same length. This is b1, this is b2, this is the height h. You average the two, then you multiply by h for the area of a parallelogram. If you talk about a cylinder, height h, make this a little bit bigger, guys. I'm kind of a little bit running out of room. I'll go over here. Come over here for something else, I guess. But let's go over here. So we got what we got. I mean, if you got the thing's got a height h, radius r, pi r squared, that area moved through a distance h, will be the volume of that cylinder. For a cone, there's ways, and there's some great proofs here, guys. It's really not something we're concerned with right now, the proofs of it, but the volume of the cone is 1/3 pi r squared h. That's 1/3 of that. It's kind of neat. So if they give you a cone with some water or a cylindrical shaped things with some water, you're getting 3 times the water over here. Look at the numbers here. This is 1/3 the size as that. So let's kind of keep that in mind as we proceed with this. Let's do a little setup on it and take it from there. Okay, everyone, let's continue talking about test number 4. We got 24 questions here. Let's take a look at them. A rug is in the shape of a square. It measures 13 feet on each side. What is its perimeter? Well, if it's 13 feet on each side, 13, 13, 13, and 13, 4 times 13 is going to be 52. The perimeter is going to be 52 feet. Number 2, the figure below shows a rectangular court. Use the calculator to find the area and the perimeter of the court. Make sure to include the correct units. The court will have a wooden floor. Which measure would be used in finding the amount of wood needed? Okay, so A and B on that one. Let's take a look. You're looking at, and you know what the symmetry is of this thing. We got 72 feet here and 93 feet here. The perimeter, they want both, okay, so perimeter and area. Well, the area is going to be length times width. It's going to be 72 feet times 93 feet. Feet times feet is feet squared. Let's see what we got here for an answer on this thing. I mean, I'm looking at it. I'm tempted to try to do this in my head. Didn't go too great last time. I'm getting 6,300 and 210, 6510, and that 6690 and 6696 I'm saying, but I don't trust me. I mean, there's a lot of stuff going on here. 66, I think it said 6696, right, at the end of that? So let's see if that actually worked out. I'm thinking 6,300, 6480, 6690, 6696. I'm going to stay with that. 6,696. Well, on occasion, even I get things right. 6,696. Okay, that's the area. Six thousand 6,696 feet squared. The perimeter, 72 and 72 is 144. 93 and 93, so you got two 93s here and two 72s. 72 and 72, 144. 93 and 93, 186. 186, 190, 330 I'm getting here, guys. Let's make sure it's right. And that's just feet. Okay, let me just make this a little bit bigger. I should check what I'm doing. I don't like leaving stuff up there if it's not for sure. 6696. It's a little easier to look at, I guess. I'm making this claim. I hope it's true. If you add these two, there's another sum just like that right here. So just double this sum. This would be 165. Yeah, 330 works. 330 works. Look at the units, though. We've gone into that. We've talked about it, and we know what we're doing. We know how to do it. So we got what we got. So it's saying this, guys. The court will have a wooden floor. Which measure would be used in finding the amount of wood needed? The perimeter is not really the issue. It's the area. You're using the area. Because you're finding, you know, you want to put a wooden floor and you want it to go all over the place. You're not building a fence. If you're building a fence, the perimeter is the one to look at. That's for sure. A strip of tape will be placed around the court. Which measure would be used to find the amount of tape needed? Perimeter. Yeah, perimeter is like a little fence, right? Whereas the area is how much you'd actually use to put things down, to get it there. Okay, so that looks good. 1 and 2 are right there for us. Find the area of the triangle below. Be sure to include the correct unit in your answer. So we have see what they got. I mean, the way this thing looks is how it looks. I mean, you got this. Perpendicular height, in a sense, is associated with 6 centimeters. This is 15 centimeters right here. And this is 21 centimeters. Well, I need this and the thing that hits it perpendicular. This guy's a little bit of a distraction at that point. These are the two, here's where the two perpendiculars happen. I'm going to take the 21, I'm going to take the 6, I'm going to multiply them together, and then multiply that product by half. So I got half, call the base 21, we'll call the height that 6, and what do we got? We got 6. Well, we can do a lot of things here, actually, make it kind of easy. We can go half of one of these, not both. Not both. You can't distribute it. When there's multiplication or division, you cannot distribute. When there's addition or subtraction, you distribute. You would distribute the half if there was an addition here and they were both within a parentheses quantity. But if it's multiplication and or division, you don't distribute. You can go half of this guy, then multiply, or you can go half of this guy, then multiply. Half of the 6 is 3. 3 times 21 is 63. Centimeters times centimeters, you know how that goes. You could also do this. What's 6 times 21? 126. What's half of 126? 63. You better get the same answer each time, guys. That's for sure. 4, find the area of this parallelogram. Be sure to include the correct unit for your answer, right? Once again. For that parallelogram, you're talking about a situation where this is 15, this is 7. They're saying this is 12, and it's not really something that's relevant for our solving this problem. This is where it happens. It's going to be area is base times height. The base is 15. The height is 7. And that's going to be it. That's going to take you there. So what we got here is base is 15, height is 7. 7 times 15, 105. Inches by inches. We've talked about this. We talked about that. So we got that. 5. A rectangular yard measuring 32 feet by 43 feet is bordered and surrounded by a fence. Inside, a walk that is 3 feet wide goes all the way along the fence. Find the area of this walk. Be sure to include the correct unit in your answer. Neat problem. We are talking about we're talking about 32 feet by 43 feet. And, you know, it's a rectangular yard measuring like this. It is bordered and surrounded by a fence. Inside of this, a walk that is 3 feet wide goes all the way along the fence. Find the area of this walk. Be sure to include the correct answer. Well, okay. I don't want to get too nitpicky on this because this is going to be bigger than 3 feet if you go right here. But right here is 3 feet. Right here is 3 feet. And right here is 3 feet. So what you're talking about is me not having drawn this correctly. For starters, let me see here. But I think everybody sees where I'm trying to go with this. We are trying to say this. So we got this. So we got this. Go 3 feet down, 3 feet over. 3 feet up, 3 feet over. And this is what you're trying to find. Well, there's a number of ways to do this. Probably the easiest way to do it is this. If this is 3 feet down if this right here is 3 feet down and this right here is 3 feet up, 3 and 3 is 6. 3 feet to go up, 3 feet to go down. 3 and 3 is 6. 32 minus 6 is 26. Right here for this guy. If it's 3 this way and 3 this way, 3 and 3 is 6. 43 minus 6 is 37. And that's this. If I find this area right here inside of this, and then find the outside area, basically here's the argument, guys. I am going to take 32 times 43, get an answer, and that's everybody. That's everybody inside here. 32 times 43 is everybody inside here. 26 times 37 is what's within here. If you subtract, what's left over is the border. So if you subtract 26 times 37, you're going to get there. So the distance is pretty fascinating, how this all plays out. There's some interesting mathematics that you could do right here to get the answer. Let's just kind of go by brute force on this one, but there is some interesting math you could do here, because this right here is 32 minus 6. This is 43 minus 6, and you know, I could kind of figure out what the heck's going on vis-a-vis that. You'd be looking at a situation. Well, it'd be neat. It'd be its own interesting problem in its own right, I guess. So what you're looking at is how would you want to do this? I'm just trying to think right here, guys. Yeah, it's pretty fascinating stuff, actually. Subject for another class, I think that would be. Let's basically take it. $32 times 43 minus 26 times 37. 414. And we'll check this, of course, guys. Even if the answer is different in the answer key, doesn't mean they're right. They can make a mistake too. But at the end of the day here, that area under consideration, 414 feet squared. It's a great problem. It's a very interesting problem. It's forcing you to kind of think it out a little bit. Let's see. Yeah, absolutely. Question 5 of 24 is 414 feet squared. And there it is. We got it. Looking pretty good, guys. So let's go to 6. Erase a little bit without taking everything out of here just yet. But question 6. Ryan is making a pennant in the shape of a triangle for his senior class photo. He wants the base length of this triangle to be 12 inches. The area of the pennant must be at least 30 square inches. The pennant has to be seen in the photo. Write an inequality that describes the possible heights in inches of the triangle. Use H for that. Okay, so what they're trying to say here, guys, is probably easier. This is easier done than it is said. It's got to be at least 30 square inches. So area is 1/2 base times the height. It has to be, the area has to be, let's put it this way. 1/2 base times the height has to, and that has to be at least 30. So it's 30 or bigger. Half is a half. B, he wants the base to be 12. This is h, greater than or equal to 30. You can pretend you're doing an equation. Just watch out if there's negative numbers present and you're multiplying or dividing by a negative number. Half of 12 is 6. Divide by a positive 6, so nothing funny happens. H is greater than or equal to 5 inches. Has to be at least 5 for this to work out. Has to be at least 5 for this to work out, guys. That was number 6. Number 7, the circumference of a circular lot is 172 yards. What is the radius of the lot? Round your answer to the nearest hundredth. If necessary, refer to the geometric formulas. Okay. Well, for this one right here, circumference is 2 pi r. What is the radius of the lot? You can do a whole lot of stuff to make this happen, I guess you could say. You could go right off the bat and say, okay, if I'm dealing with this, if 2 pi r is equal to the circumference, let me divide by the product 2 pi on each side. R equals the circumference divided by the product 2 pi. R equals 172. Okay, let me get this out of here, guys. If I could. Circumference is 172. 2 is 2. Pi is pi. They want the answer rounded to the nearest hundredth. So (172) divided by, I would put parentheses, 2 times, pi should be somewhere. I cannot believe this calculator does not have pi. It has to have pi. Okay, I'm sure it's here. Oh, there it is. Okay, yeah, I knew it had to be here. 27.3746 and then some. 27.37465. They wanted it rounded to the nearest hundredth. So R is going to equal 27.37. Yeah, the 4 doesn't bring me up anywhere, guys. So we got this. So what we have here, and that's in yards, and there it is. 8. The radius of a circle is 7 yards. Answer the parts below. Make sure that you use the correct units in your answers. If necessary, refer to the list of geometry formulas. We have those formulas, so we're fine. We can do that if we have to. A and B. A, find the exact area and circumference of the circle. Round your answers in terms of pi. So exact area, exact circumference, you've got to use pi in there. They don't want you to elaborate further. Just use pi in there when you're doing it. B, approximate the area and circumference of the circle. To do approximations, use the pi button on the ALEKS calculator and round your answers to the nearest hundredth. Well, I don't, whatever. We don't have that on us immediately right now as I'm doing this, but we'll definitely use a calculator to figure out what we're doing. All right. For 8, they want exact area, exact circumference. Area is pi r squared. Circumference is 2 pi r. Let's get down to business. Exact, you got to leave the pi. The radius of the circle is 7 yards. So it's pi times the quantity, 7 squared. You don't bring that in there. Just get it done here. 7 squared is 49. 49 pi, 49 pi, and that is the area. That's yards squared. Keep that in mind. We'll use it later. 2 is 2. Pi is pi. 7 is 7. 2 times 7 is 14. 14 pi times yards. This is what they were telling us to do. This is exact because you're not doing any, pi is about exact as it gets. You're not doing any kind of, round off with pi. You got this. So this is what A is. Approximate the area and circumference of the circle, round to the nearest hundredth. That's a different dynamic, but it ain't that bad. That's A. For B, all you got to do is go 49 times pi and then round it to the nearest hundredth. Here, you got to go 14 times pi and round it to the nearest hundredth. Again, what we got here is, this is the area that we're dealing with, and this is the circumference. And we're going to end up doing the same thing here. We're going to deal with what we deal with, but it should be pretty straightforward stuff. 49 times pi, and let's see what it does for us. $153.938. 153.938. That rounds to 153.94. We got this. Um, 14 times pi. So let's see how that plays out. $43.982. That's just 43.98 with the round off to the hundredths. 43.98. And that's it. It's pretty good. Okay? That's 8. Let's keep moving. That was 8. 9. At the park, there is a pool shaped like a circle. A ring-shaped path goes around the pool. Its inner radius is 10 meters, and its outer radius is 13 meters. We are going to give a new layer of coating to the path. If 1 gallon of coating can cover 5 square yards, that's 1 gallon of coating can cover 5 square yards, how many gallons of coating do we need? Note, the coating comes only by the gallon, so the number of gallons must be a whole number. If necessary, refer to the list of geometric formulas. Okay. You're talking about a situation like this. $13 on the outside, 10 on the inside. You're going to get the difference between area of big circle and between the two areas. There's the area of a big circle and the area of a small circle. The difference between the two is going to be the area of the circular path. Pi r squared, r is 13 times pi. Pi r squared, r is 10 times pi. The difference between the two is going to get you there. This is 169, if you do that. This is 100. Do the subtraction. That is the area in square yards. There's no square here, but we know it's square yards. That's the area in square yards. Well, let's do what we can. Let's take 69 times pi. It's going to be, like 220 maybe, somewhere in that ballpark. 69 times 216.76989. Okay, there's a lot going on here. I don't know how much I'm going to put on there. I'll say it's approximately, that means approximately equal to, pretty darn close though, 216.769893. And then some. Well, okay, so what? That's something. Every gallon of this stuff covers 5 square yards. So you can go 5 square yards over gallons or gallons over 5 square yards, but the special one, or at least the special ratio, I guess you call it special one in a sense, 1 gallon for every 5 square yards. Okay? And here I got 216.769893, and then some, square yards. That's out of there. That's out of there. Let's do that multiplication, I guess. 5 goes into here. 43.35 rounds to about 4 after that. 43.354, let's say. Well, note that coating comes only by the gallon. So we're getting 43.354 .354 gallons. Yeah, I know, you got to round up though. It only comes by the gallon, so you got to, the implication here is you got to get 44 gallons. And that's where they're going with this. Let's just make sure. Yeah, 44, right. 44 44 gallons of coating. So there we go. We can do it again. Let's keep going. So what they're saying, guys, we can say some more here. Again, that's the round-off. This would be the exact if they sold it by the 10th of a gallon, you know. Then you'd go like 43.4 just to be safe to get it there. All right, that's 9. 10, find the volume of the rectangular prism. Volume is length times width times height. Make sure the units are correct. The volume of that rectangular prism is actually a cube. It is that's 8 by 8 by 8 yards, right? So it's going to be cubic yards at the end of the day. 8 by 8 by 8. See how that works out. We've got 8 times 8 is 64. 64 times 8 is 512. 512 cubic yards. Just watch what you're doing, how you mention this stuff, how you do it. 512. Should be all right. Let me kind of be checking this stuff. I'm pretty confident it is. I think I ran across it earlier anyway. 512 cubic yards, absolutely. Look at 11. 11 is saying, see what 11 is saying, guys. 11, a company makes paper labels. A company makes paper labels for paint cans, as shown below. Each can is in the shape of a cylinder with a height of 5 inches and a diameter of 6 inches. The paper towel is wrapped around the can and covers only the side of the can, not the bottom or top. If the company makes 18 labels, how many square inches of paper will be needed for your calculations? Do not round any intermediate steps. Do not round any intermediate steps and use the pi button on the calculator. Round your answer to the nearest hundredth, probably at the end of that whole thing. Okay. We're saying the diameter, guys. Diameter of 6 inches, height 5 inches. The area on the outside is just 2 pi r, to go all the way around, times the height. Sounds good to me. Well, let's see what the area of one labeling endeavor is, and then we'll just multiply it by 5. If the diameter is 6, the radius is 3, that's pi, that's 2, and the height is 5. Let's see what we got here. We got 2 times 3 is 6, times 5 is 30. The area is 30 pi. And that's just for one of them. You're going to do 5 times that to find out what the total area is going to be. Area subtotal. You do not distribute the 5. You can only distribute when there's addition or subtraction. When there's addition or subtraction, you can distribute. When there's multiplication and or division going on only, you do not distribute. You hit it once. 5 times 30 is 150 times pi. Sounds good to me. 150 times pi. So let's see what we have here. $471.2388. 471.2389 roughly. 471.2389. All right, guys, so we had that. This has got to be inches. Inches squared. Now, we're not done. That's kind of a real rigorous look at it. Rounded to the nearest hundredth. You got this right here. That's going to go up to a 4. Area subtotal is going to be 471.24 inches squared. See what we got here, guys. Make sure I got the right units. The units should be fine. Yeah, those are inches. So okay. Oh, I'm sorry, guys. I said they made 5 labels. That would be the right answer if it was 5 labels. It's 18 labels. What am I doing? Okay, let's try that again. 1696.46. I don't know where I got 5 on that one, guys. Might have been some other problem I was looking at from earlier. 1696.46, indeed it is. 1696.46 square inches. So, well, if it was fun, I don't know if anything good comes out of this, I guess. If it was 5 labels that we're talking about, this is what you would have to do. But it wasn't. It is, let's see exactly what is going on here. We got this, that's fine. This. And right here, got 18 of those. And that's a different dynamic. I mean, at that point, 18... 18 times 30 is 540. 540 times pi is basically the ballpark of where we want to go, and that's 1696.46 square inches. Okay, guys, sorry about that. It's going to happen sometimes. We caught it, and we're okay. 1696.46 square inches. There was more to the decimal expansion, but it wasn't profoundly different from this, actually. So that was good to see. Okay, let's see what else we can say. Let's go to 12. For question 12 of 24, question 12 says, the radius of a cylindrical water tank is 5.5 feet and its height is 13 feet. Answer the parts below. Make sure that you use the correct units in your answers. If necessary, refer to the list of geometry formulas. We got that. Find the exact volume of the tank. Write your answer in terms of pi. Using a calculator, that's A. B, using a calculator, approximate the volume of the tank. To do the approximation, use your answer to part A and the pi button on the calculator, round your answer to the nearest hundredth. That should be okay. See what we can do. All right, everyone, let's keep going. They're saying for problem number 12, the radius of a cylindrical water tank is 5.5 feet, and its height is 13 feet. Answer the parts below. Make sure that you use the correct units in your answers. If necessary, refer to the list of geometric formulas. A, find the exact volume of the tank. Write your answer in terms of pi. Volume is pi r squared h. So, what you're talking about here is you've got pi. R squared is 5.5 squared times 13. 5.5 squared, let me look at this. Basically, you can say 121 times, let me try to think, guys, for a second. 121 times 25, yeah, it gets a little messed up. But what you end up getting is 325. So you got 32.25. I'm not trusting. Let me make sure this is going to be right, guys. For A, what we got is going to be not bad. You got 5.5. You're going to square it, then you're going to multiply by 13. You're going to multiply by pi. For some reason, I am looking at this. I'm thinking 121. 605. 3025. 30.25. 30.25 times 13. So let me see here. 5.5. All right, guys. I said 30.25. It is 30.25 times 13. 393.25 times pi. 393.25 times pi. Feet times feet, feet squared. So there it is. That's the exact answer because you did it in terms of pi. They want an approximate answer. So what you can do here is get the approximate answer. Take the 393.25, multiply it by pi, and you get an answer that's roughly the same size. 1235.4313. And that's the approximate answer. They're roughly the same. This is the exact answer, and if you grind it out, round it to the hundredths, you get this answer right here. So what's a big number? Well, yeah, pi is more than 3 times that, so it brings it. It's roughly the same answer each time, you guys, when you look at it. Round your answer to the nearest hundredth. We got. 393.25 times pi and 1235.43. And we are talking about volume. What am I talking about? Well, I should be talking about volume. That's to the cube. So we had feet cubed, feet cubed. Sorry about that, guys. All right, so there it is. We caught it at least. You got to catch it. Make all the mistakes you want, but catch it before you submit a final answer, right? Should be in the right place for the volumes. Okay, that was 12. 393.25 times pi, 1235.43. Again, feet cubed, feet cubed. We were okay regarding that, you guys. right above it were how many square inches were needed for problem number 11. So it's easy to kind of get in that mode that you're talking about square inches. How many square inches? Well, that was problem 11. For here, it's volume, so it's got to be cubic inches, cubic feet, cubic yards, cubic miles, cubic feet in this case. We got. We got, guys. So we got 13, and they're saying for 13, they're asking, give me an approximate volume. Round your answer to the nearest hundredth. Let's go for it. Well, as we talk about it, we know that the volume is 4/3 pi r cubed. Volume is 4/3 pi r cubed. Let's grind this out, see where it's going to go, and then do the approximation. But again, watch what you're doing when you're doing this stuff, you guys. We've got all right, 1073.476. 1,000. Well, let's see what we do have, actually. When we're doing this, they want an exact answer. It'd be 1072.476. That's the exact answer. $3,369.2827. 3,369.28 meters cubed. Well, let's make sure it's there, guys. I mean, you always check, see what you're doing. 3369.28. There it is. 3369.28 meters cubed. Sounds good to me. And, the game proceeds, guys. We just keep going like that. Over here, they want an answer. They want an approximate answer. So let's get it together. We got 4/3 pi r cubed. We got 4/3 pi. If this is the diameter from here to here, they gave us this for the figure. That's the diameter. The radius is half of that. So we're going to take 3.4, cube it. Well, let's just do that. Let's go over here. Let me stay there. 52.4053333 times pi. Well, why don't you just multiply it by pi? Let's just get to the chase here. Just see that again, guys. Forgive me. 164.6362, that's 164.64. Feet cubed. Let's just check this. It's easy. You're doing this live. It's hard to... 164.64 at the end of the day on that. Okay, for some reason, we are not agreeing here with the answer key, guys. Let's see what we did wrong, or what I did wrong, rather. Let's see. Oh, they want the surface area. Okay, well, by the way, we just answered something we didn't need to answer. That is the volume. That is the approximate volume, but that's not the question. Okay, well, we answered something not asked of us. That is the volume, however, approximated to the hundredths. As far as area is concerned, it's 4 pi r squared. It's 4 times pi times 3.4 squared. Let's grind that out. These are approximate answers. 145.2672, that is 145.27. And that is feet squared, because it's area. Feet squared is area. Feet cubed is volume. They didn't ask us for the volume. We answered it. Good practice, I guess. But this is what they are asking us. We've got to make sure we write that answer in there. 145.27. Yeah, 145.27 feet squared. Okay, let's go on. Let's go to 15. Find the value of x. Shouldn't be too bad on that one, guys. And this I have in some of my videos when I talk about trigonometry and the Pythagorean theorem, when we talk about trigonometry and the Pythagorean theorem and parallel lines and things of that nature. We know that the angles, this is not necessarily a 90-degree angle. It almost looks like it is, but we don't know that. This is X number of degrees. This is 30 degrees. And this is 30 degrees. And again, this is not really a good drawing. We know that the 30-degree angle, the other 30-degree angle, and the X number of degrees all have to add up to 180 degrees. So 30 plus 30 plus x is 180. The measurement of the sum of the angles of any triangle, doesn't have to be a right triangle, any triangle, the sum of the angles of any triangle has to be 180 degrees. You add these together, you get 60. Subtract 60 on each side. Again, I didn't draw that. That drawing doesn't look that great, but let's just use the drawing as a guide, I guess you could say. And there you go. That's what that's talking about, guys. So how that adds up. Okay, should be 120 degrees. That was 15. Let's go 16 onward and see what we can do. Okay. Let's move onward. We just did 15, as we said, right? 15. Let's go to 16 onwards, guys. For 16, they're saying an 11-foot ladder leans against the side of a house. An 11-foot ladder leans against the side of a house. The bottom of the ladder is 9 feet from the side of the house. How high is the top of the ladder from the ground? If necessary, round your answer to the nearest tenth. Basically, guys, they're constructing something like this. It's an 11-foot ladder. That's 11 feet. That's 9. And they want to know what this is. It's a good question. Well, I'll tell you what. Treat that as C. Treat that as A. Treat that as B. We know that C squared equals A squared plus B squared. C squared, the long side's 11. Call this guy A if you want, doesn't matter. And then call the other one B. So if you want, this X is B, this guy is A, this guy is the C. So 11 squared is 121. 9 squared is 81. B squared is B squared. B is equal to X, so B squared is the same as X squared. Subtract 81 on each side, and you got 40. Square root each side. So you got this. A lot of ways you could play this. There's radicals that come into play. We haven't really gone there really too much, so I'm not going to go there now for this particular course that I'm talking about. The square root of x squared is x, and this is square root of 40. Round to the nearest tenth if necessary. It looks like we're going to have to. This is not going to come out to something very easy to look at. So .3246. Round to the nearest tenth. So that's that. That's number 16, guys. Again, I'm just kind of checking this. I've been doing this long enough, guys. You got to kind of watch what you're doing. Here's 16, 6.3 feet. Sounds good to me. 17 of 24. 17, a right triangle has side lengths D, E, and F as shown below. Use these lengths to find tan x, cosine x, and sine x. We've been there. We've done this. We've got it That's D. This is angle X. That's where you center it. That's angle X. That's D. That's F. That's E. And, well, tan X is rise over the run. Rise over the run, opposite over adjacent. 10x. Cosine x. That's adjacent over hypotenuse. Adjacent over the hypotenuse. That's E over D. Sine x is F over D. There you go. We should be fine. We can look at it just to be certain here. Right. F over E, E over D, F over D. We're fine. That's 17. Let's look at 18. So they're going at it again, guys. They're kind of, luckily we have a calculator on this. The way they derive this stuff is pretty fascinating in its own right. There's some wonderful derivations that take place regarding the Taylor formula, Maclaurin series, Taylor series. Not our business right now. Find tan theta where theta is the angle shown. Give an exact value, not a decimal approximation. This is interesting, but there's a way out, and it's not too bad. Here's theta. Tan of theta is this opposite over this adjacent. The hypotenuse is there, but it's not really going to play a role, but it's going to help us solve a lot of stuff. Hypotenuse is C. C squared equals A squared. A squared plus B squared, which is the X squared. So the 5 squared plus the X squared equals 13 squared. This is 169. This is 25. This is X squared. Watch what happens. Subtract 25 on each side. Subtract 25 on each side. We got X squared. Subtract 25 on each side. We got X squared by itself. 169 minus 25 is 144. Square root both sides. X is equal to 12. If X equals 12, we're in business. The tan of theta is the opposite over the adjacent. There's your answer. 12 fifths, 2 and 2 fifths, 2.4. Don't know where they're going with that, but that's an exact answer, actually. It's opposite over adjacent. It's 2.4. And you had to use the Pythagorean theorem. If you're going to call this guy, C squared, A squared plus B squared, go for it. Plug it in, go. Find what X is. The B is going to be what the X is in this case. That was 17. Forgive me, that was 18. Find secant, cosine, cotangent, where theta is the angle shown in the figure. Give exact values, not decimal approximations. Okay, let me talk to you. We only talked about some basic stuff. I didn't think they were going to go to this, but okay, they can do that. The secant of theta is 1 over the cosine of theta. The cosecant of theta is 1 over the sine of theta. And the cotangent of theta is 1 over the tangent of theta. That's just the language they speak, you guys. So cotangent is 1 over tangent. Secant is 1 over cosine. And cosecant is 1 over sine. And the sine, cosine, and tangent we've already talked about. So they're saying this right here. This is interesting, how this is going to work out. So let's see exactly what they're doing here. For some reason, this is, when they're saying this, it's a little... See what they've done here. I think they've used some radicals here at this point. Okay, they've done a few things, so we're going to have to talk to them. Although we're going to have to see what they're doing here. Let's use the Pythagorean theorem and figure out what is going to happen here, guys. For some reason, I don't know that they wrote this correctly, but let's see what they got here. We've got this. The hypotenuse is 4. One of the legs is 3. Let's find this leg, and this is theta. Let's go 4 squared is 16. 4 squared is 16. X squared is x squared. 3 squared is 9. Subtract 9 on each side. Subtract 9 on each side. X squared is 7. X is the square root of 7. All right, so we'll put the square root of 7 right here. Here's 3. Here's the square root of 7. Here's 4. Yeah, I think that's where we're going to go. Secant of theta is 1 over the cosine of theta. So the cosine of theta, so the secant... So they want the secant of theta, they want the cosine of theta, and they want the cotangent. Secant of theta is the multiplicative inverse. Secant of theta is the multiplicative inverse of the cosine of theta. The cosine of theta is adjacent over hypotenuse. That's 3/4. That's the cosine of theta. It's adjacent over hypotenuse. That's the cosine of theta. Secant of theta is the reciprocal of the cosine of theta. That's 4/3. Cotangent is opposite over adjacent. Forgive me, tangent is opposite over adjacent, which is square root of 7 over 3. Cotangent is the reciprocal of that. So they wrote it like this. There's some things that can be said regarding this. You could do something with the radical. They're not really going there, so I'm not going to go there. They've got this. And there it is. That's 19. Okay? Let's keep going. All right, guys, just keep going. Let's get there. So for 20, 20, they're saying solve for x in the triangle, round your answer to the nearest tenth. They are saying a few things. This is 67 degrees, which is going to help us. This is x. This is 7. We know the way we can do this, there's a number of ways. There's a number of ways that we could do this, but here's a good way. What is opposite over hypotenuse? It is the sine. The sine of 67 degrees is going to be opposite over hypotenuse. Say that again. Opposite side divided by hypotenuse. In other words, opposite over hypotenuse is the sine. If you multiply by x on each side, you get to here. Now you got to be careful, you got to be patient, and you got to solve for x. Now you're going to divide by that quantity on each side. On each side you're going to do that. When you do that, you're going to get this. They want you to round this whole thing. Round your answer to the nearest tenth. Sounds good to me. 7 divided by the sine of 67 degrees. So divided by the sine I got 7.6045. That's 7.6. Make sure your calculator is set to degrees, not radians. Radians are valid, but if they gave it to you in degrees, you got to make sure you're answering the question in terms of degrees. Rounded to the nearest tenth, we got 7.6. Let's just quickly look. That's 7.6, absolutely. All right, 21. Round your answer to the nearest tenth of a degree for something like this. Now here we're going to do the inverse sine, or inverse tangent. Looks like inverse tangent to me. So what we have here, you got x degrees, you got a 9 right here, you got an 18 right here, it's a 90-degree angle. The tangent of x is opposite over adjacent, which is 9 over 18. 9 over 18 is 0.5. If you want to find out what x is, you get the inverse tangent of the tangent. I got 0.5 here. I'm going to get the inverse tangent of the tangent. The inverse tangent of the tangent, the inverse tangent of the tangent of x is x. The inverse tangent of 0.5, I don't know. We got the calculator, you got to go for the inverse tangent on that, because they gave you enough data. They gave you the data to know what the tangent of x is. Now tell me what, they gave you the data that 9 over 18 is 0.5. That's the tangent of x. Where does 0.5 come from? What angle does it come from? Well, let's get the inverse tangent to actually get it. So what you have here is $26.56505. What do they want it rounded to? I think it was just the nearest tenth. Round your answer to the nearest tenth of a degree. 26.565. That 26.565 is 26.6. Okay, not bad. Okay, so that was 21. Let's have a look. 26.6 degrees, absolutely. 22. 22 says a ramp 27 feet long rises to a platform that's 20 feet off the ground. Find x, the angle of elevation of the ramp. Round your answer to the nearest tenth of a degree. Not too bad. What we're talking about is something like this. Not the best drawing in the world already, guys, but that's all right. We need to find out what x is. This is 27. This is 20. Opposite divided by hypotenuse is the sine. The sine of x is 20 over 27. If you do the inverse sine on each side, and I'm going to have to do something on the calculator with 20 over 27, but that's all right. Inverse sine on each side. The inverse sine of the sine of x gets you back to where you started. The inverse sine of this is going to get us there. I'm going to go 20 divided by 27, then I'm going to get the inverse sine. So, let's see what we got here. $47.7945. 47.7945. 47.79 is 47.8 about. So round to the nearest tenth. How about 47.8? Not bad. That was 22, 47.8 degrees. You got it. Round your answers to the nearest tenth. Solve the right triangle. What they're trying to say here, I'm not thrilled by the terminology, how they did it, but capital B, small b, and small c. They're giving you this. The times I want to draw a right triangle, I can't do it, it seems. All right, let's see what we got here. How about that? Make that a 90 degree angle. If this is 52 degrees and this is 90 degrees, finding capital B shouldn't be too bad. 22, this is small b, this is small c, and this is big B. Well, wait a minute. If this right here is 90, if this is 90 and this is 52, if this is 90 and this is 52, then it's 142. 142 plus 38 gives you the 180. So I got the 38 right there. Angle B is 38 degrees. There's a lot of ways to do this, but the law of sines is probably the best way to do it. You could go sine of B over B. Sine of B over small b is equal to the sine of big C over small c is equal to sine of A. I mean, there's a lot of stuff here, guys. I can call this guy, if that's B, I can call this big C. And I can call, if that's B, we can call this guy A. And A is equal to small a is equal to 22. Basically, law of sines goes something like this. You can write the law of sines in two different ways. You can put the signs underneath and put the regular numbers on top, or have the regular numbers on the bottom and the signs up top. I usually put the signs up top. This is where you want to go. Now, we already know that if you sum the angles, if you sum all the angles of any triangle, they have to add up to 180. If this is 90 degrees and this is 52 degrees, you add them together, 90 and 52, 90 and 52 is 142. 142 plus 38 gets you to where you want to go. So angle B is 38. The other ones are going to be pretty interesting to do. So what we're going to need to do is a couple ways to do this, I think. Just get more chalk, everybody. Okay, so I want to get that. Let me go with the C at least then. I don't know how big C is, but I do know that the sine of C is 90 degrees. Forgive me. I do know that big C is 90 degrees. Sine of 90 degrees is 1, so 1 over C equals, use whatever you want at this point, guys. I mean, we can use the sine of 52 degrees over 22, so we'll use this guy. Sine of 52 degrees over 22. If two things are equal, the reciprocals are equal, so you got this. If, sounds good to me. 22 divided by the sine of 52 degrees. $27.918, so I got 27.9. See if it comes out. Rounded, 27.9. So that's that. Find B. Well, it doesn't matter which way you go. I can go the sine of 38 degrees over B is equal to a lot of stuff. I mean, I can use this right here. So let me see here. Let's go to the next one. Let me see what I could say here. I just found C. B is, and again, you can write them like this, or you can just get, if all these are equal, all the reciprocals are equal for our purposes. So let's go B over the sine of B, B over the sine of B, the sine of big B. Sine of big B is 38 degrees, rather. I'm sorry. And you got, the other one is, I just go with the C, I guess. C is 27.918. 27.918 over the sine of 90 degrees. 27.918 over the sine of 90 degrees. Sine of 90 degrees is 1. You got 27.918 right here. You got b over this, sine 38 degrees. Multiply by sine 38 degrees on each side, 27.918 sine 38 degrees. Now again, there's a little bit of a round off that I did. Hopefully it's not going to be a big problem. 27.918 sine 38 degrees. Times the sine. I got it on the calculator here. Times the sine. $17.188. That's 17.2. Okay, guys. I think we're okay. I think we did it right. It's probably easier to do than it is to explain sometimes. Hopefully we get it right though. We got 38. Yeah, we came out okay. Angle big B is 38 degrees. Side small b is 17.2, and side small c is 27.9. Not bad. We're there. So that's that. The last problem they're saying a lot of stuff here, guys. For 24, they're saying for 24, the figure below is a right triangle with side lengths TUV. Suppose that the measure of angle T does not equal the measure of angle U. Complete the following. And they say a bunch of things here. Let's go for it. It shouldn't be too bad. It's quite wordy, but it shouldn't be too bad. Okay, guys. A lot there. Let me see how we can always refer to how it looks as well. But for 24, this is big angle U, big angle T, and big angle V. Small v is the length of the hypotenuse. Small u is the length of one of the legs, and small t is the length of the other leg. This is a right triangle. Complete the following. In TUV, that's this triangle, angles T and U are complementary, supplementary, neither complementary nor supplementary. Suppose that the two angles, suppose that the measure of T does not equal the measure of U. They both have to be less than 90 degrees. So they're both complementary. Complementary angles are less than 90 degrees. Or actually, yeah, they're each less than 90 degrees and they add up to 90 degrees. Because it's got to be 180. If this is 90, the sum of these two also has to be 90, because 90 and 90 is going to be 180. So these either are complementary. Complementary. That's part one. That's part one. Part two, use T, U, and V to fill in the blanks. Make sure to use the appropriate uppercase or lowercase letters. Let's go. This is 2. They want the sign of big T, the sign of big U, the cosine of big U, and the cosine of big T. The sine of big T is opposite over hypotenuse. The sine of big T is opposite the T over the hypotenuse, and the hypotenuse is V. Sine of big T is opposite over hypotenuse. That's T over V. These are low case. These are low case. This is high case. This is low case. Sine of U. It's opposite over hypotenuse. That's U over V. All low case in the answers here. Cosine of U. Cosine of U is adjacent over hypotenuse. That's T over V. No, it's the same answer as this one. Well, yeah, look how the question's asked, though, too. I mean, that makes sense. What is the cosine of T? Cosine of T is adjacent over hypotenuse. That's U over V. They did this on purpose to show us, depending what angle you're referring to, you get certain answers. And there are some repeats. Notice, you know, how this and this are the same. We'll look at the relationship that's present, you know. Same thing here. Look at the relationship that's present, you guys, when they're doing this. So, okay, yeah, that's fine. That's part two. Part three, select all of the true statements. Select all of the true statements. Sine of T equals sine of U. That's not true. Sine of T equals cosine of U. Yes. So sine of T equals cosine of U. These are all big numbers too, big letters, okay? Sine of T equals cosine of U. Yeah. Let's see here. Sine of T equals, yes, sine of T equals cosine of U. Cosine of T equals cosine of U. Cosine of T equals cosine of U. No. Cosine of T equals sine of U. Yes. Yes. None of the above is true. That's not true. Some of them are true. Sine of T equals sine of U, not going to work. Sine of T equals cosine of U works. Cosine of T, so sine of T equals sine, yeah, right. Sine of T equals cosine of U, and cosine of T, cosine of U. Okay, let me just make sure they're here, guys. I think I could just finish this, but it should work out. Right, sine of T, sine of U, it ain't going to work. Sine of T, sine of U, not going to work. Sine of T, cosine U, yes. Cosine T, cosine U, no. Cosine T, sine of U, yes. I did all that. And then the none of the above, no, that's not true. I mean, you just got answered two of them. They are complementary angles within. Complementary angles within a right triangle have, if the sine of one is something, that equals the cosine of the other. Fill in the blank. Sine of 79 degrees is equal to the cosine of the complement of this, which is 11 degrees. If you had something looking like this, if this was 79 degrees, and then this would have to be 11 degrees. The sine would be, let's say this is CAB. The sine is A over C. The sine of 79, the sine of 79 degrees is A over C. The cosine of 11 degrees is A over C also. And that's where this is coming from. That is it. It's a pretty long worksheet. But we're looking good, guys. It looks good. Let me talk to you guys a little bit later regarding some of this stuff. Thank you for your time.